We may be a little shaky in the execution of it, but we at least have the formula memorized. All right, so a couple of things to remind you of. The negative b just means that it's the opposite of b. This number will not always be negative. Okay, this number will not always be negative. A lot of times it will turn into a positive number. It's just the opposite of how it appeared in the equation. Something that people screw up on a lot. When they square this b right here, if b was negative, they don't put parentheses around it, and it messes this whole thing up. So you got to put parentheses around that number before you square it, and I'll talk about the rest of it kind of as we look at an example. You still have to be equal to 0 in order to be able to use this formula. So let's look at number 21 from there on your worksheet. We've got 9x squared plus 22 equals negative 4x minus 8 plus 11x squared. Since moving it to the right side only requires me to move 2 terms, I'm going to do that in this case. I'm going to move everything to the right side. I'm going to subtract the 9x squared from both sides, and I'm going to subtract the 22. I don't think we have much of a problem with this, but just make sure you line it up with the like terms. So we've got 0 is equal to, I'm going to write it in standard form here. X squared comes first. 11 minus 9 is 2. 2x squared. X comes next, minus 4x, and then negative 8 minus 22 is negative 30. Now, this is optional. I think it's a pretty good idea. After you get it in standard form, come over to the side and list your A, B, and C. And that helps me when I'm grading things so that I can see your thought process. Was it an issue with identifying the coefficients, or was it an issue with the quadratic formula? Where's the problem here? So if I can at least see your A, B, and C, I know that is or is not the problem. Bless you. All right, time for the quadratic formula. X equals the opposite of B. B was negative 4, so that's positive 4. Plus or minus the square root of, here's where I was talking about, you've got to put parentheses around the negative 4 before you square it. Minus 4 times A, which is 2, times C, which is negative 30. All over 2 times A. Now, I know that the equation does not have parentheses there in the denominator, but some people like to type this in all at one time, and if you don't have parentheses around the denominator, it's going to mess up your answer. So just be in the habit of at least writing it down, so maybe it'll get in your calculator if you want to type it in all at one time. But I'm going to break this down. I'm not going to type it in all at one time. I'm going to see what's under my square root first. So we got 4 plus or minus the square root. I'm going to find out what that number is, and it's over 4. So let's see what's in here. We've got negative 4 in parentheses squared minus 4 times 2 times negative 30. And you wonder why I emphasize that so much. It's because somebody's still going to do it, and you're going to get the wrong answer, and I'm going to be a little frustrated because I've said it like 500 times. Put it in parentheses before we square. All right, 256. 256 is not on my list of perfect squares. My list of perfect squares does not go that high, so I need to check and see if it is a perfect square. Can I take, if I take the square root in the calculator, is it going to give me a whole number? In this case, it does. So 16 squared is 256. So we've got 4 plus or minus 16 over 4. Now I'm going to break this down and do it by hand one at a time. So we've got x equals 4 plus 16 over 4. So 4 plus 16 is 20. 20 divided by 4 is 5. There's one of my solutions. My other solution is 4 minus 16 over 4. So 4 minus 16 is negative 12. Negative 12 divided by 4 is negative 3. Now, I would love for you to do that by hand without your calculator, but if you do use your calculator, guess what? We can't type it in all at one time. 4 minus 16 divided by 4 with no parentheses gives you 0. 0 is not the correct answer. You got to put parentheses because there's more than one term in the numerator. You have to put parentheses around the 4 minus 16 over 4 if you're going to type it in all at one time. -3 is the correct answer there. All right, so there's another little thing that I want to remind you of. Now, guess what? If you get whole numbers as your answers when you do the quadratic formula, that means that this was factorable. 2x squared minus 4x minus 30 is factorable. You can take out a GCF of 2, and then it's really, really easy to factor. But I wanted to show you that even if it can factor, the quadratic formula is going to work. Some people prefer the quadratic formula. I know it takes a little bit of time. I broke it down more than it necessarily needs to be broken down. You can do it a lot faster than I just did it, but I wanted to prove that point. Okay, let's look at number 22. This one is not factorable. I'll go ahead and tell you that ahead of time. 15p squared minus 9p minus 23 equals 9p squared. We got to start the same way. Got to get everything on one side. Let's move the 9p squared since it's over there by itself. So 15 minus 9 is 6. 6p squared minus 9p minus 23 equals 0. Again, I know a lot of you may think that this is overkill, but it can't hurt to do it. A is 6, B is -9, and C is -23. I don't think that I mentioned this before, but just in case it comes up, because I'm not going to do an example like this, if I were missing my P term right here in the middle, what would be the value of B? 0. Okay, if the P were not here in the middle, then B would be 0. If 23 was not here on the end, if I didn't have anything there, what would be my C? 0. Okay, so if any piece is missing, that constant is 0. Okay, for your quadratic formula. All right, so here we go. X equals the opposite of B. B was -9, so it's +9. Plus or minus the square root of -9 squared minus 4 times A times C, all over 2 times A. All right. What's under my square root here? -9 in parentheses squared minus 4 times 6 times -23. 633. Now, I told you that this one was not factorable, so that means 633 is not a perfect square, but I'm going to check it just in case. Just in case I lied to you. I try not to do that. But the square root of 633 exists, it's just not a whole number. Okay, we can take the square root of 633. It's just not a whole number. It's not a perfect square. So, here's what we got to do. We got to try and simplify this square root. Did y'all do that in math too? Did you simplify square roots? Okay? All right. So, some of you are shaking your head, saying yes. I'm going to go over it just to make sure we're all on the same page. So, we're trying to see, is 633 divisible by one of my perfect squares? For some reason, 9 is popping to my head. I'm going to try that one first. Okay, 9 didn't work. Okay, how about 16? Let's try 16. Nope. I know 25 is not going to work. I want to try and get the biggest one. So how about 36? Nope, this is not working out. So maybe I need to go back down to 4. Now it doesn't work either. After 36 is 49. After 49 is 8 squared 64. Okay. So apparently, unless I'm just missing something, this one does not reduce. I know it's not divisible by 100. Oops. Okay, so this is a square root that does not reduce. Okay, 633 does not reduce. So you're off the hook here. That is your final answer. 9 plus or minus the square root of 633 over 12. Now, just to show you, in case I totally missed something. Did anybody find anything that I missed? Yes. 3? Okay, it's divisible by 3, but 3 is not a perfect square. Okay. I divided by 9, right? Yeah. Okay. All right. So it is divisible. It does have factors, okay? 633 does have factors, but the question is one of its factors a perfect square, okay? And it's not. But one way that you can kind of check this is you can type this in and type in the numerator and divide it by the denominator, and you can get the decimal approximation, and you can check it against your answer choices, okay? In case you just couldn't find how it's simplified, type in the answer choices and see which decimal matches, okay? That one did not simplify. Let's look at number 23. Okay, number 23. 12x equals 11x plus 8 plus 4x squared. We need to move the 12x, so we subtract it from both sides. So 0 is equal to, put it in standard form, positive 4x squared minus x plus 8. So a is 4, b is what? Negative 1. Okay, be careful with that. Those tend to throw people for a little bit of a loop. Okay, b is negative 1. So here we go. X equals the opposite of b, 1 plus or minus the square root of negative 1 squared in parentheses minus, almost put a plus, 4, that still looks like plus, minus 4 times a, which is 4, times c, which is 8, all over 2 times a. So let's see here. We've got 1 minus 16 times 8. Negative 127 all over 8. Can we take the square root of a negative number? No. Okay? You cannot take the square root of a negative number because there's no way to multiply a number by itself and get a negative. However, in Math 3, we are introduced to this wonderful world of imaginary numbers. Remember yesterday when I was showing you the solutions to a quadratic equation, if it didn't cross the x-axis, there were no real solutions, but there were 2 what we call imaginary solutions. So, reaction number 1, anytime there is a negative under a square root, you are going to automatically take it out and you're going to put an I in front of your square root. I is defined as the square root of negative 1. Okay, I is equal to the square root of negative 1. So we just took out the square root of negative 1 and replaced it with I. Okay, then we need to see if 127 reduces. Okay, let's see if 127 is divisible by a perfect square. I'm thinking we run into another one that's not. So 2 squared, 3 squared, 4 squared. I doubt it's divisible by 16. I know it's not divisible by 25. 36. 49. No, I think we're in the clear. Okay? 127 does not reduce. It does not reduce. So that's it right there. Do y'all want me to try and find an example that does reduce so we can go back over that? Y'all need me to go back over the reducing the square roots, or y'all just want to give it a shot? Okay. Y'all give it a shot. We'll check these